We've got panelists in place. We've got participants coming in. We'll do housekeeping in a moment. Thanks for being here today, everybody. We are at the top of the hour. I'm going to give it about another 60 seconds and then we'll get cracking because we have an action-packed agenda today. It's a great perspectives. So let a few more people get in and then we'll do our welcomes and such. We should one day try to do a contest, see if anybody can identify where the graphic was, where the graphic was shot or what it depicts. That'd be kind of a fun contest for next time. Okay, so we are a minute after the hour. I'm going to get started and we'll continue letting folks in. So good morning or good afternoon, depending on which time zone you're in. I'm Steve Werblow with the Conservation Technology Information Center. And it's a pleasure to welcome you to the latest in our series of webinars on satellite-driven monitoring technology, looking at crops and now rangeland around the continental or the contiguous US. We're very honored today to have a group from several different organizations that are involved with the technology that you'll see today. We've got Allison Thompson from the Foundation for Food and Agriculture Research for the national perspective, Matt Jones from Regrow Ag, whose technology we're viewing, Matt Bain from the Nature Conservancy, a major supporter and user of the technology, who's going to share some perspective on some of the uses for the new data. And Dave Gustafson from Conservation Technology Information Center is going to walk us through the visualization tool and tell us what we've got as results. You will find this webinar as soon as we archive it, as well as our previous webinars on the CTIC.org website. And CTIC is very excited to be able to share these data with you and the webinars. We also want to thank our members and sponsors who make the website and the things we do possible. So you can see them on the screen. We also want to invite you to other webinars and events that we've got going on. Our Conservation and Agriculture Tour is kind of a cornerstone of our calendar. That's coming up June 10th and 11th in Arkansas. We welcome you to join us there. Leading up to it, we've got some great webinars, one on rice stewardship partnership and the importance of rice in Arkansas. That's May 16th, as you see on your screen. We've got another one on technology tools and grower-based approaches for implementing effective conservation. That's going to be May 23rd. And then we've got another one following the tour, part of our Farmers for Soil Health series of technical webinars, this one on soil health and grazing cover crops. You can find links to these. Callie's putting them up in the chat. And so we encourage you to join us for those. Speaking of chats, we are going to have a Q&A at the end of the program. And so I encourage you to enter any questions you might have as they come up in the little Q&A. You'll see the tab at the bottom of your screen with the little voice balloons. And even if you don't have a question that you're typing in yourself, have a look at those and you can upvote ones that you find particularly interesting. So with that, I'm going to hand over the microphone, the virtual mic, to Allison Thompson from the Foundation for Food and Agriculture Research. Allison, thanks for being here.
Great. Thank you, Steve. Thanks for the invitation to join and give a little bit of an introduction. I am a scientific program director with Foundation for Food and Agriculture Research. Just going to give a few minutes of introduction of who FAR is and why we're supporting and really excited about the work you're going to hear about today. FAR was established in 2014 in the Farm Bill to connect funders and researchers and farmers to pioneer the next frontier of agricultural innovation. We build collaborative partnerships, often public-private partnerships like the one we're hearing about today, to support science that addresses today's food and agriculture challenges and really lead the way toward collaborative science to achieve affordable, nutritious food grown on thriving farms. So, ambitious agenda. One of our priority areas within the foundation is sustaining vibrant agro-ecosystems. So we have a range of research programs really looking to deepen understanding of how agriculture interacts with the surrounding environment. This is just one of the areas we work in. If you worked with FAR before, this is really integrating the work we do on soil health, water management, and climate smart agriculture into one priority area theme. One of the ways we work is through consortia on the next slide. So we work to bring partners together around a common research agenda or common challenge in order to really accelerate research that is actionable, that is really practical and relevant. So the Ag Mission Consortia on the next slide is our signature sort of climate smart agriculture initiative, really bringing together farmers, ranchers, and scientists to accelerate adoption, really an aim to achieve scale and speed of adopting climate smart agriculture practices. On the next slide, you see our really kind of theory of change is that by bringing this collaboration together and having researchers and producers work more closely, and not just agricultural producers, meaning farmers and ranchers themselves, but the other stakeholders who are working with them throughout the supply chain. By bringing all of that closer to the research, we can produce more practical and science-based solutions that are more readily adopted, which will mean faster adoption and transition over to climate smart practices. That's really what we're aiming for. On the next slide, we have been working within Ag Mission with our 3 founding partners, which include McDonald's, PepsiCo, and the Nature Conservancy, to fund research for the past 2.5 years. We actually have an impact report that'll be coming out in just a few weeks, so kind of a midterm report on where we've been. So in addition to the 3 founding partners, we have 31 additional funding partners who've contributed to one or more research projects. We have over 30 million that's been awarded and currently 17 active projects. So we've also reached out into the community through requests for information to understand what researchers and other stakeholders feel is needed in this space. And we've done 2 competitive solicitations so far. We will be doing more, so stay tuned for that as well. And looking forward, so the Regrow program, the Optus program that's been done through Regrow and CTIC and TNC all working together is really one of our sort of signature collaborations, bringing together public and private sector with a commitment to transparency and making data available, and also addressing what's been a real gap in the data, really understanding grasslands and rangelands. So one word, it's an incredibly diverse system. We desperately needed better data and tools to better characterize the productivity and change and how management is impacting all of that over time, and to really understand the soil carbon and emissions impacts of the activities on these rangelands. So with that, I am going to hand things over to Matt Jones from Regrow, who's going to walk us through the data. So thank you all very much.
All right, thank you, Allison, very much. Thank you, everybody, for being here today. My name is Matthew Jones. I'm with Regrow Ag. I'm a senior scientist there. I've been there for a couple years. By training, I'm a remote sensing scientist and ecologist, and sort of focused in the grassland space for the last 5 to 6 years or so. And I'll be talking today about sort of monitoring the continental U.S. grasslands at scale to inform conservation and management. And before I get going, I would definitely want to thank FAR and TNC and CTIC for making this opportunity available just to talk and for their constant support in all of this. And so you can go ahead and take to the next slide. So a quick overview of what I'm going to address today is We're going to talk about monitoring grasslands, sort of where it stands now, the underlying data behind what we're talking about today, and then show you a couple examples of how that data is being used to track and quantify really the most pressing threats to grasslands, and how we're doing actually a pretty wonderful job. The science is advancing at a rapid pace, and that's really promising. And then I'll dive a bit deep to the methods behind this, of how we produce this data. And it's just kind of key there for everybody to understand where this data comes from and the algorithms behind it. And then I'll launch into the products themselves that can be used to inform conservation and management, and give you a slightly different view of that data than you might see on the CTI website, which is nice because the data there is available, and so you'll be able to sort of manipulate it in these ways as well. So we can go ahead, next slide. So monitoring grasslands, the data that underlies everything you're seeing on the CTIC website is essentially these two core data sets. The first one is a plant functional type percent cover data set. And by percent cover, what I mean is at every 30 meter pixel, you have a percent cover of each of those 5 functional types that you're seeing there, which means at a given pixel, you'll see that it's 50% perennial grass, 20% annual grass, 10% shrubs, and the remainder is bare ground. It's no longer the traditional categorical classifications that we used to have for a very long time of this pixel is nothing but grass. And we'll talk about that in just a minute when we look at the other algorithms. So that data is available 2001 to the present. It can go back even further in time because the satellite imagery is available for that. The next core data set is net primary productivity. And we have that estimated for both perennial grasses and annual grasses, which we just call perennial herbaceous and annual herbaceous. And then we can sum those together to get total herbaceous production over every 30 meter pixel across CONUS. These data are available annually, and then the NPP data is also produced every 16 days. So to give a seasonal look, which is then summed up to produce that annual value. Like I said, 2001 to the present ended a 30 meter resolution. The two plots on the right just show you examples of if you were to pick a location, a field, a paddock, and plot that out, you would see these changes in percent cover in that upper right plot there, how they bounce around from year to year based on responses to drought or management. And then the bottom figure essentially would be net primary productivity through time in that same space, seeing the contribution of the perennial component, the contribution of the annual component, and then the total. So be able to track these two things and line them up together to determine which portion is really driving the production. And before we go to the next slide, I will say, this is all we sort of come to take this kind of data for granted. It's been around for like 5 years or so, and it really came from a bit of a renaissance in remote sensing processing and remote sensing monitoring of grasslands. The coupling of the release of the Landsat data archive, the coming online of Sentinel-2 from the ESA around 2015 gave us this absolute wealth of data. 8 to 10 day repeat of the entire globe at 10 to 30 meter resolution, unheard of. You bring in Google Earth Engine and those types of cloud computing processes, you no longer have to download the data. You no longer have to deal with these massive data loads. Everything is accessible via a browser. And then you combine that with the massive amounts of field data over grasslands that have been collected across government agencies and NGOs and everywhere else. This kind of perfect trifecta has come to fruition where we really are in this heyday of a wealth of data. And Dave, you can go to the next slide. And really, so I'm just presenting all these different data types that are out there that have come out from these technologies, right? Up in the upper left-hand corner, that's the plant functional type data that we were just talking about. Down in the bottom left, these are different cover data sets that have come out of USGS. You have the RC map data set, a shrubland fractional components data set through time that Matthew Riggi and his team have produced. Super valuable data to dive into. Really specific data as far as the exotic annual grasses has also come out of USGS Eros and DeHall and the publications there. Again, this fantastic data set that goes down to the species level of invasive grasses. So super valuable for monitoring and tracking management responses. For the production side, you basically, advancements started happening years ago of saying, let's get away from this 1 kilometer NPP data that was the dominant thing that was used everywhere and say, can we do this at 30 meter now? And we can. And so we get these very high resolution estimates of production. That data can then get turned into above ground biomass that is monitored seasonally and through time, that bottom right example, essentially getting at that really valuable resource of forage. How much is there? What is the seasonality of it? How is it responding to drought and deluge? All of this data is now available. We have this wealth of data to monitor our grasslands. It's just so valuable and great. And what's been happening now, right, is using this data to track really and quantify the threats to grasslands. And we can hop to the next slide. And I pulled a bunch of examples here of papers that have been recently written that capitalize on these data sets to really give us a look that we've never had before. And these huge pressing threats are woody encroachment, exotic annual grasses, and cropland conversion. And I'm really just going to hit on those first two in this slide here. The third one is a massive one as well, but we won't go into it today. In the upper left, you can essentially see the value of these plant functional type covered data set through time, right? That photo on the left is a field plot that was taken initially back in the day as a grassland plot. And we didn't have that data from the past. And if we looked at the current 2014 plot data, it shows it as being basically a woodland, right? The picture shows it as being a woodland. This has suffered from massive woody encroachment. When you go back in time and you look in the 80s and early 90s, you see that it wasn't just a woodland, there was grass there. And so having this perspective really gives us this great insight. Morford et al. In 2022 took this type of data and said, how much forage have we lost to this woody encroachment across the US? And it's massive, right? The lost production was valued to be between $4.1 and $5.6 billion. This is a massive issue, right? A massive threat to our grasslands that we need to gather this data for and try to make progress on. And this is the type of papers and research that really drive that. If you're thinking about the exotic annual grasses, we can look at the right-hand side. This was a great paper by Smith et al. In 2022 that essentially looked at the elevational ascent of exotic annual grasses in the Great Basin of the US, right? It was sort of initial theories were like temperature constraints, right, are going to limit that expansion. While using these data, looking at it year on year, we could see that it's actually starting to occupy those spaces. And we need to consider that when we do our management actions and monitoring. And then finally, in the bottom right-hand corner, we have these great data that's getting at the species level maps across the Western US of these exotic annual grasses and our perennial grasses, seeing them in contrast to each other, where they're battling it out, where one is taking over the other. And again, through time to be able to monitor and manage, really just fantastic data sets. So that was more of my general overview there of monitoring grasslands and what we're doing to address these threats. And now we're going to take a step back to the data itself that underlies these products. And I'm going to talk a bit about the methods behind them. So to develop the plant functional type data, I have this sort of big broad over here. Essentially what involved here is training data, right? Massive amounts of training data that we then capitalize on Google Earth Engine. So we have all these points. We can extract the remote sensing data over those locations through time, which is a massive compute cost, but Google Earth Engine makes this available with very little effort. We then have all of that data to develop models and do model training, which we do in the Vertex environment. And you'll see these icons across the top. Essentially, we're using the Google environment of applications to drive all of this. This model is built upon the temporal convolutional network model that Allred et al. In 2021 developed. A wonderful advancement there, and we continue to sort of advance it with the Vertex AI environment. We're able to then take that model and deploy it at scale and make predictions at every single 30-meter pixel across the continental US from 2001 to the present. And like I said, if we needed to, we could go back in time. And again, this is the percent cover of each one of those functional types at every 30-meter pixel across CONUS for this long time stretch. So it's really sort of this valuable data set to look through time. And this data set became the key to driving an advancement in the NPP methodology and models. You can go to the next slide, where the NPP model itself we're using is actually not brand new. It's quite old and well established because it works great. And it gives you the option to modify it as you need without disrupting the sort of biophysical basis of the model. It's the Monteith model of light use efficiency. And in the super basic description of it here, number one, plant production, plant productivity, it's directly related to the amount of solar energy a plant can absorb. Number two, the ability of that plant to convert that energy into biomass, we call its light use efficiency. How efficient can it take that energy and convert it to biomass, right? And thankfully, we can estimate that to a good degree of accuracy. But that parameter, that LUE, it's dependent on the plant functional type. A grass has a different LUE than a shrub, different than a tree, different than corn, right? They all have their own different light use efficiencies. So that's a pretty key part to this. Step 3 there is that we can estimate that amount of energy absorbed because it's directly related to vegetation indices that we can measure, like NDVI or EVI or LAI, right? So we have all 3 of these components here. And the small component down below is these light use efficiency. It's obviously constrained by moisture and temperature. And so we bring that factor in as well. But getting to the PFT dependent parameter, and go to the next slide, that's where the advancement of the functional types really came into play, right? Up there, we have a picture on the upper left of a grassland, right? A grassland / shrubland, right? It's a mix of bare ground. It's a mix of annuals and perennials. It has shrubs there as well. Prior to these data sets, that pixel, that location got treated as a single class. It was either said to be a shrub, or it was said to be a grass, or it was said to be bare, whatever it might be. It didn't have that heterogeneity. The data set we have now takes that solid green pixel you see on the left and allows us to say, no, it's broken up to a bunch of components. What we can do is we can allot that NDVI signal for that pixel to these different plant functional types and know that in the dead of summer, it's the perennials that are driving the NDVI. In the shoulder seasons, it's usually the annuals that are coming in early, capitalizing on the early spring moisture to green up real quickly and develop seed. We're able to capture these phenologies. And when we can do that, and we know the amount of cover that's with air, we can allot the NPP to these different plant functional types and get very specific estimates of the NPP in that pixel. 80% of it is coming from the perennials, 10% is coming from annuals, this percent is coming from shrubs. It creates this really valuable data set to be able to look in detail at these locations. And we can go to the next one. So the final set of data that you're going to find on the CTIC website is this estimate of NPP deviation from climatic potential. So this is taking that NPP data that I was just talking about that's specific to annual and perennial herbaceous components, so total herbaceous production, or NPP. And we've essentially developed a model to say, what would the NPP be if we only had climate as the driver? If we only use precipitation, temperature, and an aridity indexes to say, to predict what the NPP would be at those locations. Now, the response to these things is definitely has, geographic components to it and drivers. So we developed an individual model for every ecoregion, every level 3 ecoregion across CONUS, so that the parameters for each of those precipitation, temperature, and aridity could vary based on the ecoregion. And we ran ecoregion scale models across this time period just to predict NPP at every pixel. So now we have a prediction. We have an estimate to say, if this was just based on climate, this is what NPP would be. And then we say, well, what was the observed NPP? What does the light use efficiency model tell us the NPP would be in that year? We therefore then have a residual. We have the difference between the prediction and the observed. We look at that through time, and that can tell us whether that location is going beyond its climatic potential. Is it producing more than we think? Or is it actually the opposite, where it's actually not achieving its climatic potential? So these are sort of key questions and can help us identify locations to say, why is it not reaching its climatic potential? Is it management? Is it not as resilient to drought as we would hope and think it might be? You can start asking these key questions. So those are really the data set behind what you're going to see on the CTIC website and its methods. And we can go to the next slide, Dave. So the products you'll find are, they are all summarized by at Huck 8 scales and at crop reporting district scales. In part, you heard me mention this before, right? 30-meter data across CONUS, across over 20 years. It's a massive amount of data, right? It takes a great deal of compute time and processing. So done at this scale, it allows us to look at regional metrics that are done like under a common framework and then prioritize sort of areas of interest. And then also on the big picture, it can be this initial step at looking at a CONUS-wide assessment and finding, which HUCs you might want to focus on and which CRDs you might want to focus on. The data here takes basically 3 forms. there's the annual data, which is essentially just the annual average NPP for that Huc8 or that CRD, and then also the plant functional type data for each year, the average annual perennial and grass sort of coverage in that CRD or Huc8 for each year. So that's the annual data. We have on top of that the trend data, where we've then taken this series of 7 years of data and fit trend lines to it to basically say, is it increasing, is it stable, or is it decreasing over time? So we do that with both the NPP data, and then we do that with the plant functional type grouping as well. So you'll be able to see whether tree cover is increasing, stable or decreasing, grasses, etc. The final bit is that last slide that I showed on the methods, is the modeling results that shows whether the grassland productivity significantly deviates from that climatic potential. And again, summarized as a percent area for the Huc and CRD scales. And so now we'll jump in. I have a few examples to show these data. And so this first map is basically showing the fraction of grasslands in each crop reporting district that display a stable or increasing perennial forb and grass cover across these 7 years. Okay, so in each one of these slides, I have the little box on the bottom left that describes that data set again from the previous slide. And so what you can see here is our red-orange areas, right? That would be, I have it as fractions here, but you can also think of it as percentages, right? Those would be the places that say, between 50 and 70% of that area is displaying stable or increasing perennial forb and grass cover, which it is kind of good, but at the same time, that says that 30% of that location is actually experiencing a decrease in perennial forb and grass cover. So that's why I have them as red here. There's sort of these highlighted CRDs that you might dive into deeper, while the blues and the greens are essentially the ones where like the good majority of the grasslands in that CRD are doing quite well. And go to the next slide, please. So a similar graphic here, but looking at that herbaceous NPP trend through time, right? And so I basically have done the same thing to say, what is the area that displays a stable or increasing herbaceous NPP through time? What fraction of the CRD grasslands are displaying that? And again, you can see sort of our red and orange CRDs are saying possibly positive ideas that 70 to 80% of the area is stable or increasing. But at the same time, that also means that 20% is not, right? The 20% is decreasing in terms of herbaceous NPP over these 7 years. So again, you look into these areas, maybe you couple the two maps together and really look at places that are suffering from both of those conditions and say, okay, that's where I need to drill down a little bit more and investigate what's happening. We can go to the next one, please. So now this is that third, the modeling results of the deviation from climatic potential of production. So in each one, again, this is the fraction of the grasslands in each CRD that is displaying herbaceous productivity that significantly negatively deviates from climatic potential. So again, the deviation is going downward. It's not achieving its potential in terms of what the climate can offer. And so what's nice is that these fractions are relatively low, but we can see that in this case, the blues, I should have probably flipped this scale. The blues are our areas of focus here, where we have areas that are not quite hitting that climatic potential of production that we would like them to hit. And so we can dive deeper, like I was saying. Is this drought induced? Has there been large scale management happening on the grasslands in these areas that we can then sort of dive into and look into more detail on? And then I have one more slide. And so what I didn't talk a great deal about today was the DNDC soil biogeochemical model results that are offered also on the Grasslands via the CTIC website. I'm not a soil scientist nor a soil modeler, so I can't give a great deal of background on this. But suffice to say, basically this was done as these coarse DNDC model assessments of current trends in soil organic carbon and greenhouse gases over grasslands. Simulations were done at this ecoregion scale, again, with at least 180 simulations per ecoregion. They basically found that running more simulations per ecoregion didn't influence the results, so that was kind of a nice cap of simulations to run. And what's provided here is this aggregated level data at each ecoregion of the output of the DNDC products. which you can see there, soil organic carbon, methane, nitrous oxide, both direct, indirect, and total. And these are provided at a temporal scale, annual, every year from 2015 to 2021. And so this slide here was more of a reminder that that data is there. Please go explore it. We do have Chris Dorich from Regrow here on as a panelist with us for later on for the discussion and questions. And he's our specialist there as far as D&DC goes, and probably can provide some great answers to questions you might have regarding this data. And with that, I thank you, and thank you, Austin, for the opportunity to present. And I will pass it now on to Matt Bain of TNC as we transition these slides.
Thanks, Matt. Yeah, while Dave gets those teed up, I'll just introduce myself a little bit. I'm located in Western Kansas. I work for the Nature Conservancy as our Southern High Plains grassland project manager. And so I'll talk a little bit about kind of a conservation use case for this kind of information, talk about how we can apply this kind of information to our conservation work in the Southern High Plains. Go ahead and advance there, Dave. So just a little bit of an overview of the project that I work on. This is the Southern High Plains Initiative. It's part of the Great Plains grassland biome. This biome is experiencing a collapse. We are losing from 2008 to 2016. We've lost 10 million acres of grassland, about 4 million acres of that in conversion to cropland, and about 6 million acres lost due to woodland expansion. And then from 2016 to 2020, lost another 10 million acres of grassland in the Great Plains grassland biome. So these grasslands, these Southern High Plains grasslands, are part of the most vulnerable and least protected terrestrial system. So really important that we work together to try to outpace threats in these grassland landscapes. Go ahead, advance, please. So this gives you an idea of kind of the project area that I'm talking about a 71 million acre area there that's outlined in the thin red line, roughly the size of Colorado, centered on the Oklahoma Panhandle. We've got the Nature Conservancy's Resilient and Connected Lands Network there in green. One of our conservation targets, the lesser prairie chicken, current range in pink, historic range in hash lines, and just kind of give you an idea at the scale that we're working in there, and identifying those last intact grasslands that function at a population scale for some of these conservation targets, that if we lose these last intact places, then we really will have nothing left in these systems. So go ahead and advance, please. And the way we think about this is in terms of grassland ecosystem services, and really all grasslands provide and contribute to one of these services or more. When we think about food supply, beef production, the Great Plains produces about half of all U.S. beef. It brings about $58 billion in annually, important to these local communities and livelihoods. Obviously, grasslands provide clean air and water, important source of secure carbon storage. About 90% of grass annual biomass production is below ground. About half that is replaced every year, becoming available for this very secure source of carbon storage. And then native wildlife habitat biodiversity, an example of that, how important that is, and how, again, this collapse is affecting the system. Since the 70s, bird populations, grassland birds have undergone the most significant decline of any other terrestrial biome. So really important in terms of the native plant, and that getting at some of these factors and some of these trends is really important to long-term conservation and of biodiversity. Please advance. The way we think about this is really a continuous spectrum, right? So on the left, you have just keeping grass green side up, not converting, is really important. That's a huge ecosystem service, providing clean air, clean water, keeping keeping in grass instead of woodland is an important service. And then in addition to that, you might have some forage-based management planning provided through some of the information that Matt shared, for example, that herbaceous NPP. And then, woody invasive management, again, to keep it in grass. Then maybe on top of that, and top of those producers providing just those services, maybe they're managing for a biodiversity target. And then on the right-hand side, looking at durable commitments to that kind of management. And so this is kind of that spectrum of continuous improvement. And we have a variety of tools that we implement in these landscapes that help producers meet their goals and achieve that durability out there on the landscape. And go ahead and advance, please. And the reason I think that I'm talking about this is at the scale of these last functional grassland systems, what we call generational grasslands. It's important that we're able to meet producers where they are. The combination of ecosystem services that they're providing in that area, and recognize that it all contributes, and that we want to make sure that these all add up strategically in these last functional grassland cores. And so you might have one property that's keeping grass in grass, keeping the trees off, and has a forage management plan. And then you have another one that has all those things, but has a term commitment to providing those services. And you might have another one that has a permanent commitment to providing those services through a conservation easement. So making sure that all those different services are and those tools that are working to incentivize those services are all working together in the same intact system, something at like a 200,000 acre scale. Go ahead and advance, please. And again, going back to the project area, just wanted to flash back and show Kansas, Oklahoma, eastern New Mexico there, southeast Colorado. Go ahead and advance. And bring it to the scale of the tool that we're talking about here today on the CTIC site, and the kind of those functional groups that Matt was talking about. Here we have annual grasses, perennial grasses, bare ground, shrubs, trees. And the way that we can use this information is that trends in herbaceous NPP can serve really as an index to forage production. That is an index to habitat quality for a diversity of native grassland species. And then we have that trend and functional group or vegetation class is also really critical. Again, thinking about things like woody encroachment and annual grasses. So geospatial tools like this platform, this public facing version, certainly that we're looking at, but then also the data behind it, can really help with a phase one kind of effort to identify hotspots where grassland ecosystem services might be in decline. Something like that expected, that deviation from expected climate potential that Matt was talking about. It can also help us track progress at the scale of those high priority grassland cores. So with that, I'll just kick it over to Dave Gustafson with CTIC.
Dave, do you have your audio? Oh, there you are.
Be patient, sir. Still recovering from my concussion. Some of you may know that I took a very bad tumble here a few weeks ago, so I'm still in recovery mode. But it's great to be here with you all today. And before I pull up my slides, I did want to pause here for just a moment and say that we're very blessed actually to have the support of the folks at St. Mary's University who developed the tool that you'll be seeing here in just a moment. We didn't have them present here today, but I did want to acknowledge the great work that they did because as you'll see when we get there in just a moment, that the capabilities of the visualization tool have been significantly enhanced. So I just wanted to say a quick thank you to them before getting into things here. So, okay, multitasking as always. I hope you're all able to see that. Today, I'm just going to give you a little quick peek of the new visualization tool. I did want to acknowledge, as we always do when we talk about this work, that we've had a whole bunch of sponsors over the years that have helped make both the Optus Croplands product as well as the new Grasslands product that you're seeing today here, which is specifically through a grant through FAR. Thank you, Allison, and also the Walton Family Foundation, as well as contributions from TNC. So you've already heard this, I think, but the new products are available for the entire lower 48 or CONUS, continental US, for all croplands and grasslands here in the country. The calculations, again, are done at the pixel scale, as was highlighted by Matt, but they are spatially aggregated, which helps protect grower privacy. The data sets that are now available on the website are as indicated. We've heard a lot about the grasslands or grazing lands products here today, but just as a reminder, we do have the croplands product. The version that you'll now see on the website when you go there is the same data set that has been available since September of 2023. But as indicated here on the right, there will be an updated data set being made available for Optus products on croplands later this year. The products that we make available through Optus have much greater temporal frequency than the Ag Census. And as mentioned in a recent blog that some of you might have read, we do think it's important to keep these data coming. We are making the data available now for the years 2015 through 2021, but we are hoping to continue annual updates to the Optus data set in particular, so that we can be certain that all the funds that are going into cover crops and other practices are really having the desired impact and not have to wait another 5 years for the next Ag Census to really find out. So some of the changes to the visualization tool, some of you may have already tried to get into the system, so you've discovered this for yourselves, but they are now based on Esri mapping software behind the scenes through the expertise at St. Mary's, rather than Tableau, which results in much higher quality maps, as well as some additional data layers being available. However, one change that we have implemented is a requirement for folks to log in. There's still no charge to the data, they're free, but as with many government websites, et cetera, we've decided it's important for us to be tracking who's accessed the information, and this will help us follow up with you for future partnering opportunities. But when you first come into the system, you'll see the menu look like this up at the upper right. And then once you hit the login button, you'll create an account, a one-time experience that hopefully, if you have your browser set up properly, you won't have to repeat that. And then after you've done that, you'll be able to access all the data that we're talking about here today. So I'm now going to stop sharing yet again and get over into my browser so that we can see the tool itself as promised. So I believe you're all able to see that. I've already gone through and selected grasslands. And so here are all the data sets that Matt was describing earlier. We call it vegetation types, the different types of land cover in these areas, as well as the net primary productivity metrics that Matt was describing. I'll open up one of these now. So you can see the layout that's used on all of the screens, and you can see that I'm accidentally hitting the map there. But on the left-hand side of the screen, you'll be seeing a time series across the chosen geographic area for net primary productivity. And on the right, a map. And again, as with the previous products, we can zoom in on a particular part of the country here. For something like this, we might want to pick, I'll pick Kansas, just to zoom in on Kansas, which obviously has very high net primary productivity. And then you can also modify the date range as with our previous products. I'm just going to use my backup here to get to another form of data that are now available on the website. And this is how we've chosen to represent the trend information. If you, again, you can zoom in on a particular state. In this case, I'm going to go ahead and pick North Dakota here, and zoom in there, and you can see that in the upper northern tier CRDs within this particular state, that we do apparently have a trend for decreases in NPP relative to what we would have expected based on climate conditions. And as Matt briefly alluded to, this could be, you could make an inference here that this is related to management changes or other factors. In this particular part of the country, I doubt it's encroachment by forest, but those sorts of things are a possibility, obviously, as well. So again, the data are out there. We believe the tool continues to be quite intuitive. I will try to show you some of the additional layers here, but rather than go into that at the moment, I'm going to say that we invite folks to check out the website for themselves. It just launched here yesterday, and we'll be meeting with the development team again on Monday. And so if you do encounter things that aren't working quite right, or you have comments, please do feel free to send those to me directly, because we understand, given the site is so new, that there may be some things, user experiences, that are not optimal. So with that, I'm going to stop sharing and turn back control over to Steve Werblow, who, as with all of our past webinars, has served as moderator to help take us through some of the questions that have been asked so far, and also to introduce our additional speaker, who's Chris Dorich from Regrow Ag, who can field questions specific to DNDC.
Great. Thank you, Dave. So we're gonna play off the recency effect. You are since you're fresh off of your part of the presentation, when people come to the visualization tool, is there an opportunity to download data, or is it all purely visual? And yeah, I guess what's the next step if people want to use these data for research?
The data are not available for download, and that's been the case for quite a while here at CTIC. However, there are folks who are interested in collaborating directly with Regrow on data at a particular spatial scale are encouraged to approach them directly, and that's been our model of the partnership for quite some time, and even potentially getting data at a much finer resolution would be available by working directly with Regrow. And I know they've collaborated with a number of academic partners, as we've talked about on previous webinars, looking at analyses, for instance, the impact of crop insurance on cover crop adoption, et cetera. And there have been all sorts of different kinds of very interesting academic projects that have happened. We had a whole webinar on the topic of water quality, for instance, here last year, that folks might go back to. One thing I didn't mention about the updated website is that we now have a special page dedicated that lists all of the past webinars for those who want to go back and review some of those presentations that were made last year, and actually all the way back to 2020. So
Absolutely. And for folks who want to do that, if you look at ctic.org and go down the data pull down, you'll see all kinds of resources, including these visualization tools, which are both fun and amazingly powerful. It's really, really cool tech. Now, speaking of tech and the power of what this product brings to the marketplace, I'm gonna read a question that was put into the Q&A just to make sure that we can answer it verbally. And this is going to go to Matt Jones. The question was, most of what was just discussed is already available at the pixel level from the Rangeland Analysis Platform, the RAP, which is maintained by USDA ARS. So what are the new innovations that are being launched here?
Thanks, Steve. Yeah, I can definitely answer that. So yes, very similar data available via the RAP. Some of the innovations essentially are sort of bringing this all sort of in one place and having it summarized at these different scales and through time. If someone is not super savvy at being able to manipulate these massive raster data on the scale of gigabytes and terabytes of data, that's what this sort of enables essentially. So that's one of the innovations that this tool brings. Another one is essentially that modeling the differences, deviations from climatic potential. That is data that, as far as I know, hasn't really been done to this scale, and also being done at this sort of very specific ecoregion scale allows, basically allows it to be sort of malleable to the locations, to the climate, that can be far more specific in different regions of deserts and plains and things like that. So that would really be a big innovation piece of identifying places that aren't achieving their climatic potential, because as Dave mentioned, it's sort of our first insight to ask, like, why is it not getting to that potential? What is the driver? Or if it's above that potential, what conditions are occurring in that huck that would drive it to become a more productive location than a neighboring huck or somewhere else? So it really sort of just that first step of being able to come to the site and see it on a very large scale and start asking the questions of which direction you should be going and diving into. Do we know, I'm just curious, like, I can answer more directly. Do we know who asked the question, or I know that doesn't matter?
No, it just came across as anonymous attendee.
Oh, okay.
So, but while we're talking about RAP, there's another one from Patrick Lenderum, wondering if current NPP by plant type, which is the former RAP data, is available via API or an Earth Engine catalog. For a while, it was only updated until 2021. Is that something you know the answer to?
I think so. In that time period, the Hornada took over the Rangeland Analysis Platform, and so the USDA ARS Hornada station essentially is the one involved in producing that data. I'm not sure of the status. I believe it's available as an Earth Engine asset. So they'd have to explore that a bit more. I don't know if it's going to be listed in the data catalog though, of the Earth Engine data catalog.
Got it.
Updated.
But ARS will have more, particularly the Hornada station folks.
Right.
More
correct.
insight. Okay. You're still in the hot seat, Matt. We got one more for you. Are these models generalizable to other geographies like international, or limited to where you have specific training data?
Yeah, so it's a great question. So the functional type models, yes, those become limited to geography because basically the innovations of those in the very beginning and the ones that are involved in the USGS sites as well, they all use sort of specific field data and plots. There are publicly available data sets, like in the case of the BLM, has a massive AIM data set that is available across much of the US. But when you move to new geographies, especially new countries, yeah, it's going to be a challenge because you're going to need to find some level of data, field data at that scale to run the models, at least in this form and how these models currently exist. The NPP data, on the other hand, that is a pretty globally applicable model. It is something you can run if you're like, and in most cases, in the majority of cases, it's going to work okay to say, hey, a classification of that land cover type at a 30-meter resolution, it's categorical. A 30-meter pixel identified as grass or identified as a mixed forest or whatever. The NP model is very adaptable in that way. You could certainly run this same exact type of model over these different locations and get great estimates of net primary productivity. And if you search the literature, you will find this model has been applied everywhere globally across multiple spatial resolutions, temporal sort of cadences, and for the most part done a very good job at those estimations.
Awesome. Now, last one till we give you a break.
No, it's fine.
Popped up from Dan Kaufman. I'm curious why the 30-meter resolution was chosen versus other resolutions. Can you shed a little light on that?
Yeah, certainly. It's really it's number one, the nature of the data. So originally these data were being first driven by Landsat, which has a 30-meter resolution for the bands that we're working with. And Sentinel came on board, and that basically has a 10-meter resolution. But really what you find, there's a trade-off between, most people always say, well, why not just finer and finer and finer resolution? Why not get down to a meter if we can? Well, it's a huge trade-off between the data load and the processing load when you get to that resolution. And when you're looking at, say, a large pasture that's 400 acres or something, or 100 acres, a 30-meter sample is getting you a lot of samples within that single field every 8 to 10 to 16 days. Do you really need 10-fold more samples every cadence and everything? And that just it creates this massive amount of compute. So it's really the application and the degree of data that you're working with, where some people argue, no, it's worthwhile to go to the 10-meter resolution. Great. Just know that you need to scale up your compute and scale up your cost to match, basically.
Makes a lot of sense. All right, I'm going to take the spotlight off of you, Matt, so you can get a drink of water or whatever you need. I'm going to quickly answer Leah Windsor's question. She says, will the slides be available after the presentation? And what I'll ask you to do is if you can email north@ctic.org. We'll get you whatever slides we can. And also, we're going to archive this or put the recording up on the CTIC website. Again, ctic.org, pull down at data. So then all of the display as well as the conversation will be recorded there, which may also be an easy way to access things. While we have a moment, I'm going to ask Chris Dorich from Regrow to just tell us a little bit about what DNDC is as a model, because it's a fascinating and powerful data set that complements the data that we've been talking about today. And I just want to make sure people know what that brings to the equation. North, okay, did he say north? North like the cardinal direction, N-O-R-T-H, like hotel.
Thanks, Steve. Yeah, so a little background on DNDC. DNDC is the denitrification decomposition model. It's a process-based model. So we are able to simulate management events on these fields, whether it's agriculture, cropland, or grasslands in this case, using that model to simulate the biogeochemical processes that are occurring on that field, impacted by, both things like climate, the soil conditions that are inherent on that site, as well as the management events. So in this case, we paired it with some of that remote sensing data to constrain the model to more accurately represent the biomass being represented on these fields, and therefore, constraining the biomass to be more accurate to what we're seeing from that remote sensing data, trying to constrain that aspect of it to then more accurately simulate the soil carbon and nitrous oxide emissions that are occurring on these simulations on these grasslands.
Wonderful, thank you. We are coming up to the last couple of minutes. We've got a question here. Are you able to track where or who in the US is accessing this data on CTIC's platform most frequently? Dave, I'm going to put that one to you.
Well, actually, Callie, who's here, has much more familiarity with exactly what we're able to do behind the scenes with respect to IP addresses, et cetera. But yes, in principle, we are able to, just as with any website, know where folks are coming from an IP perspective. But the new thing that we have done is we've asked folks to log in now. And so we'll have a list of folks and their organizations who are accessing the data. I did want to take just a moment before we completely leave here to say that I actually found the button that was missing earlier. I couldn't find it before. So there are now, and this is new with the visualization tool, a whole bunch of additional available base maps that you can add. Some of the more interesting ones that are useful would be the street maps, obviously, just to kind of locate yourself. So it's this little icon up here if you're on the website. And I apologize, I wasn't able to find that earlier, but anyway, just from my side here, I just want to say a huge thank you to the other speakers and then hand it back over to you, Steve.
Great. And on that note, yes, thank you indeed to all of our speakers, to our sponsors who keep the lights on, and to the folks at St. Mary's in Minnesota who did a phenomenal job with the visualization tool, taking this tremendous and really powerful data set and making it into something that I really encourage people to go visit and explore. It's fun and it's absolutely fascinating. So with that, we have more webinars, as we mentioned in the chat, that we'd love to see you on. This will be posted on ctic.org, and we will keep you posted on future webinars as more data and more application studies come to light. In the meantime, thank you very much to everybody, and have a great day.
Thanks, Steve. I'm gonna end it.
Okay, thanks, Callie. I'm sorry to have thrown you under the bus with the email address, but I realized that was probably the most